We're going to look now at an algebraic situation in which there are more than three variables. And the example I'm using is an equation called the ideal gas equation. The point about this exercise is you don't have to know what these variables stand for that are in this equation. We'll look at that later when we study the gas laws. But the equation reads PV equals nRT. What I want you to know is that I can manipulate this equation in such a way as to solve for either any of these five variables in the equation. For example, if I wanted to solve for V, I would basically multiply both sides by 1 over P in order to isolate V. In other words, if the question is what is V, then I multiply both sides of this equation by 1 over P, and I'm doing that just to make sure that the P cross cancels on the left-hand side of the equation. The whole point again about algebra is you have to do to both sides exactly the same thing. I've done this in order to make the P's cross cancel across the fraction bar, leaving me an equation that would usually be written nRT over P. On the other hand, if I wanted to solve for example n, I can start with the same equation, PV equals nRT, and multiply now by the quantity 1 over RT on both sides, because I'm trying to get rid of the R and the T. So again, if I multiply the left-hand side by 1 over RT, I have to also multiply the right-hand side by 1 over RT. And notice when I do that, of course I've done that to make the R and T cross cancel on both sides of the equation, leaving nothing but n, because that's what I wanted, was to find n. So rewriting that, usually you reverse the direction and say n equals PV over RT. Sometimes you're going to find also that we want to solve for a ratio of variables. There's nothing wrong with doing that. In fact, often what will be solved for is the ratio n over v when we're looking at the ideal gas equation. So again, starting with my equation, PV equals nRT, I can first isolate the n by multiplying both sides by 1 over RT as we did before. That gives me the equation PV over RT equals n. And then I can divide both sides by 1 over v. That's going to isolate, that's going to get v out of the left-hand side of the equation and put 1 over v on the right-hand side of the equation. And that will give me n over v equals p over RT. So now I have an equation that I've manipulated for my own purposes. I wanted, and you'll hear later why I might want, n over v as a ratio. So the point of this exercise is to show we can manipulate all these symbols around without ever thinking about what the numbers might actually be. And that's an important point. Students often make mistakes by plugging numbers in and manipulating equations with the numbers. It's much better to first manipulate the symbols and then plug in. So in this last example, if I had given you a value for P, I had given you a value for T, given you a value for R, this is the point at which I'd plug the numbers into the equation and then run those numbers through my calculator.